Welcome once again. Hello everyone. Myself Dr. Ruchira Goel from Department of Applied Science and Humanities, Ajay Kumar Garg, Engineering College, Ghaziabad. The topic which I'll be taking today is application of partial differential equation, and my subject which I'll be teaching is Mathematics 4, whose code is KAS 302/402. The contents of today's topic are method of separation of variable with some examples that will be discussed on method of separation of variables. Now, in this method, we assume that the solution will be the product of two functions, each of which involves only one of the variables. Now, as I can perceive that there is a problem when we solve partial differential equations sometimes. So, we want that the solution of the equation be converted in such a manner that it is easy to be solved. So, this particular method actually converts partial differential equations into ordinary differential equations which are much simpler to be solved. So, let us consider the first example to understand the process. Now, suppose we have to use this method of separation of variable to solve the equation del u by del x equal to 2 del u by del t plus u. This u means this u has to be a function of x and t. Fine. So, we are given that u x comma 0 is equal to 6 e to the power minus 3x. This x comma 0 means that the value of the function u is being taken at t equal to 0. So, this is the initial condition. So, initial condition means those conditions which are taken when the time is considered to be t equal to 0. Now, suppose we consider the solution of the equation to be as u equal to xt, where this capital X means function of x only. We can also write this as the notation capital X bracket small x. This means that this capital X is being taken as the function of small x only. Also, this capital T, this can be written as capital T bracket small t, that means function of small t only. So, now we will take the derivative of u with respect to small t because we require this del u by del t. So, when we take the derivative, partial derivative, this x is considered as constant, and hence we are left with capital X dt by dt. So, substituting in equation 1, this is our equation 1. This is our equation 1. So, if we substitute the values of del u by del t, del u by del x, so we get from here, we get del u by del x as t dx by d small x. So, if we substitute these values in equation 1, we get this equation, and this dx by d small x is denoted by x dash, this dt by d small t is denoted by t dash. So, we get this equation t x dash equal to 2x t dash plus xt. So, if we take x common, so this becomes 2t dash plus t into x equal to this equation. Now, we will use this equation and rewrite this as x dash upon x equal to 2t dash upon t, because the initial equation was tx dash plus x 2t dash plus t. So, dividing this entire equation, if we divide this entire equation by xt, that means u. So, we get this equation x dash upon x equal to 2t dash upon t plus 1 equal to minus p square. This minus p square we are considering as the ratio constant. That means since two ratios are equal, one is this ratio, another is this ratio. So, if they are both equal, we will consider them as equal to say minus p square. And now considering them equal to minus p square one by one, so in the first instance we are taking x dash upon x equal to minus p square, which gives us dx by dx plus p square x equal to 0, and hence we get dx upon d capital X equal to minus p square dx. So by variable separable method, if I integrate, I'll be getting log of x equal to minus p square x plus log of constant. So I am getting capital X as some constant e to the power minus p square x, and similarly I'll consider 2t dash upon t equal to minus p square plus 1. I'll get this because this is my second part of the ratio. So from here, if I again separate the variable, this t dash means dt upon d small t. So dt by dt. So this dt upon dt, if I replace this equation in this manner, this implies 2 dt by dt into 1 by t equal to right hand side, that is minus p square plus 1. So this t goes on this side, and hence I get this t goes, this t remains associated with this capital dt, and this is dt goes this side. So I am getting dt upon capital T equal to minus p square plus 1 by 2 dt, and hence on integration I get log of t from this side. Minus p square plus 1 upon 2 is considered as constant with respect to t, so I get minus 1 p square plus 1 by 2 into t, and then plus log of constant, and so capital T becomes C2 e to the power minus p square plus 1 by 2 into t. So now I want u basically, because that was my solution which I am required to find. So from equations which I have considered, second, third and fourth, I will be getting u as xt is equal to C1 C2 e to the power minus p square x minus p square plus 1 by 2 into t. So this u I'll compare with the given condition. Now the given condition was u at x comma 0 was C1 C2 e to the power minus p square x. So if I put t equal to 0 in this equation, so this entire value becomes 0, and I am left only with the right hand side, that is C1 C2 e to the power minus p square x. So this value is considered equal to 6 e to the power minus 3x, which was given to us. Hence on comparison I can see that this C1 C2 is coming out to be equal to 6, and this minus p square is coming out to be equal to minus 3. So on comparing I'll get C1 C2 equal to 6 and p square equal to 3. So my solution becomes ux comma t equal to 6 e to the power minus 3x minus 2t, because if I consider in equation 5, from equation 5, left hand side was ux comma t, and right hand side was C1 C2 was 6 from here, and e to the power minus p square was 3. So this is 3x minus 3 plus 1 by 2t. So 3 plus 1 by 2 means I'll be getting this solution, that is 6 e to the power minus 3x minus 2t. So this is my answer. Now let us consider one more example for solving another set of equation, that is del 2u by del x square minus 2 del u by del x plus del u by del y equal to 0. Now it has second order derivative involved in it. So how to proceed? So let me consider again u as a function of two variables. Now this time the independent variables are x and y. So since independent variables are x and y, u is considered as function of small x and small y. So this capital Y is function of y only, this capital X is function of x only. We may also write this as equivalent to ux comma y equal to x, sorry, x x y y, that means function of x and y. So again I will take those derivatives which I require to be substituted in the given equation. So in the given equation I require three derivatives. One is del 2u by del x square, another is del u by del x, and the last is del u by del y. So I'll find out all three of them. So del u by del x turns out to be, considering y as constant, it turns out to be y dx by d small x. That means dx by dx, and del u by del y similarly in the same, by the same process, turns out to be capital X dy by dy. So del 2u by del x square, if I take derivative of del u by del x, which was y dx by dx. So if I take derivative of this del u by del x, I will be getting del 2u by del x square as y d2x by dx square, because y will remain constant. Hence, substituting all these values in given equation, that is equation number 1. Let me show you. The given equation was this one. This was the given equation. So this was my equation number 1. So if I substitute these values in equation 1, I am getting y d2y by dx square minus 2y dx by dx plus x dy by dy equal to 0. So in symbolic form I can write y x double dash minus 2y x dash plus x y dash equal to 0. So this gives me, if I divide this equation by u equal to x y, so I will be getting x double dash minus 2x dash upon x as one set and y dash upon y as another one. So this equal to 0. So I'll take this entire thing on the right hand side. So I am getting x double dash upon minus 2x dash upon x equal to minus y dash upon y. So again I'll take both the ratios, since these are equal, I'll consider them as equal to minus p square. And this ratio on considering equal to minus p square, at one at a time. So the first one, x double dash minus 2x dash upon x equal to minus p square, gives me x double dash minus 2x dash plus p square x equal to 0. To solve this, I'll use ordinary differential equation, because this equation is having auxiliary equation. This equation is of the form d square minus 2d plus p square x equal to 0. To solve such equations, we will substitute d, we will replace d by m. So auxiliary equation becomes m square minus 2m plus p square equal to 0. This m on solving is found out to be equal to 1 plus minus under root 1 minus p square. Since right hand side is 0 in here, so CF will be found and PI will be 0. So CF turns out to be, since these two values, that is m equal to 1 plus under root 1 minus p square and m2 equal to 1 minus under root 1 minus p square, these values are distinct. Hence complementary function will be given by C1 e to the power 1 plus under root 1 minus p square into x plus C2 into e to the power 1 minus under root 1 minus p square into x. Hence capital X turns out to be C1 e to the power 1 plus under root 1 minus p square into x plus C2 e to the power 1 minus under root 1 minus p square into x. So this is my equation number 2. Now I need to find capital T also. So to find capital T, capital Y. So to find capital Y, I'll consider the other set, that is minus y dash upon y equal to minus p square. So this gives me dy by dy equal to p square y, and I'll use method of separation of variable. I'll separate this capital Y, I'll consider below dy, and this will be p square y. So on integration, I'll get log y equal to p square y plus log of constant, and which gives me capital Y as C3 e to the power p square y. So I'll be getting u as product of capital X and capital Y. So in this situation, there was no initial or boundary conditions were given. Hence, this is the complete solution which I am required to find. Now, there can be a possibility that in the first example, we have considered the initial solution as we were given the initial condition as ux comma 0 form. In this form it was given, but instead of this form, some other process can be used to write the initial condition. So let me consider the next example. So to solve by method of separation of variable, this equation 4 del u by del t plus del u by del x equal to 3u. Here in this equation, we are given u as 3 e to the power minus x minus e to the power minus 5x. Initial condition here is mentioned in this way, when t equal to 0. So instead of writing u x comma 0 equal to 3 e to the power minus x minus e to the power minus 5x, we have used another way. We can also write this condition as u at t equal to 0 is equal to this value. So all these are symbolic notations which one must know before proceeding for solving the equations, and if you are comfortable with understanding initial condition, then only you can apply to find the final solution. These initial conditions are given basically because we need constants to be removed from our solution in one way or the other, so that the complete solution can be found. Now let us proceed with the solution part. So since here x and t are independent variables, so u will be considered as function of capital X and capital T. I have already told you that I can write this notation form as well. Now this del u by del t needs to be found, and del u by del x needs to be found. So to find del u by del t, consider x as constant. So this is x dt upon dt equal to x t dash, and del u by del x equal to t x dash. In the same way, considering t as constants. The thing to be remembered is, when we are considering derivative with respect to x, we are considering t as constant. When we are considering derivative with respect to t, we are considering x as constant. So the derivative, whichever variable is being considered with respect to, the other one will be considered as constant, and we will take derivative that many number of times, which is the requirement of our equation. So if instead of del u by del t in this equation, suppose we are having del 2u by del t square, then this means that the derivative of u has to be considered 2 times with respect to t. So our given equation will decide how many times the derivative has to be taken. Now, so we have found our required derivatives. We will substitute in the given equation. So in substituting in the given equation, we will get, so from the given equation, if we substitute, we get 4x t dash, because from this equation which is given to us, if we substitute, we get 4x dt by dt plus t dx by dx equal to 3xt. Now in all the all the possible ways, method of separation of variables says that we will divide this entire equation always by capital XT or capital XY, whatever the set of independent variables. That means whatever we are considering U as, we will divide the entire equation by that. So on dividing the entire equation, we are getting 4t dash upon t plus x dash upon x equal to 3. Now again we need to take two ratios. So either this 3 will remain on this side with and I will replace this over here, or else I can take this 3 on this side as well. It's my choice. So suppose I take 3 with 4t dash upon t. So this 4t dash upon t minus 3 is equal to minus x dash upon x, and I consider that this ratio to be equal to p square, suppose. Now one thing is to be seen, that this taking this 3 with t or with with x variable ratio, it won't make any difference to our solution. The final solution will be balanced accordingly. So suppose I consider 4t dash upon t equal to p square plus 3. From this side, I am considering this equal to this. So I am getting dt upon t, this dt upon t, and this is equal to 3 plus p square upon 4 dt, that is d small t. So I integrate both sides. So from this side I will be getting log t, and from this side I am getting 3 plus p square upon 4 into small t plus log of constant. So on solving, I am getting capital T as some constant e to the power 3 plus p square upon 4 into this small t. So this is my capital T which I am getting. Now I will consider minus x dash upon x equal to p square. So this gives me x dash upon x equal to minus p square. Again I separate dx upon capital X equal to minus p square dx. On integration I get log of capital X equal to minus p square x plus log constant, and I will be getting capital X as C2 e to the power minus p square x. So I have found capital T and capital X. So my final solution in here will be u equal to xt. So that is C1 C2 e to the power minus p square x plus 3 plus p square upon 4 into t. But we cannot stop over here, because in this case I was given u at t equal to 0 also. This was given to me, and since this was given to me, I can find out this some way, if it is possible to be found C1 C2 or and p square. I will try and find out both. So I need to take the general solution in this case. So what I will do, I will consider u x comma t equal to some constant. This bn means C1 C2 will keep changing. We are considering, instead of C1 C2, some constant, say bn, and this is just a notation. So if suppose I change pairwise, if I change some x or t, I will get another pair of constant. For another pair of x and t, I will get another pair of constant. So I will consider all the independent solution by in the general form by this formula. That means u x comma t will be considered as summation n equal to 1 to infinity bn e to the power minus p square x plus C3 plus p square upon 4 into t. Now this summation ensures that all possible outcomes pertaining to a pair are found, and they are considered as in the final solution. Why I am taking summation? Because when u was given, it was given to be 3 e to the power minus x minus e to the power minus 5x. So there were two parts of u, 1 and 2. If there is only one part, then I need not take summation. I can simply compare both sides by putting t equal to 0 and find the solution, as I have done in the first example. But since there are two parts of u when t equal to 0, so both the parts will provide separate constants. That means when I compare with the first part of this given u, I'll get one pair of constant for bn and p square. When I compare with the second part, I'll get another pair corresponding to bn and p square. So I think that this is clear that why we, in this case we are taking summation, because this is important. This creates doubt when a student attempts questions that why summation is being considered in this particular case and it was not there in the previous case. But it is very much evident that if it is this given condition is having two separate parts, then we need to take summation. Otherwise, without summation also we can compare our answer. So when t equal to 0, I substitute t equal to 0, so this becomes 0. I am left only with sigma n equal to 1 to infinity bn e to the power minus p square x. And on comparing this with 3 e to the power minus p square minus e to the power minus 5x, what I'll get, this will be compared one at a time. That means first I'll compare this and next I'll compare this. So if I have a look, in this situation, this constant coefficient of e to the power minus p square x, that means e to the power minus x is 3. And in this case, the coefficient is minus 1. So here it is 3, here it is minus 1. Whereas when I look at the power of e, that is minus p square, in this case, e to the power minus x is there. So I am having, on comparison with minus p square x, I am having p square as 1. And in this particular case, if suppose I will take e to the power minus 5x equivalent to e to the power, sorry, let me write again. I'll compare both the parts. So in this first case, if I compare 3 e to the power minus x equivalent to some bn e to the power minus p square, so I get bn to be equal to 3 and p square equal to 1. And in the other case, minus e to the power minus 5x, if I compare this as equivalent to bn e to the power minus p square x, I'll be getting on comparison bn as minus 1 and p square as 5. So I hope that this is clear that how we will compare. So moving on to the next slide, I can see that p square is 1 and b1 is 3. b1 means we are comparing the first term of the given u, and p square is 5 and b2 is minus 1. And if I substitute these values in the given equation, in the previous equation, that means in this equation, this is my equation number 5. So if I substitute bn and p square, so I'll get the solution as 3 e to the power minus x plus t minus e to the power minus 5x plus 2t. So we can see that how by method of separation of variables, the complicated equations which otherwise would not have been in a situation to be solved by any other method can also be solved by taking these functions, these equations in the form of ordinary differential equation. So this becomes much simpler. We require initial condition only if we want to find the constants, otherwise the solution will be in terms of constants. And boundary conditions, if at all they are required, then they will be provided to us. We will inculcate them also. So this is all for today. Thank you.